So now let's talk about weather. Weather is the state of the atmosphere at any time, like now. What's happening outside? Is it raining or is it sunny? Is it cloudy? Is there a hurricane? Um, so we're going to start with a few weather basics. First, hot air rises. As you heat up an air mass, it will go up in elevation, just like a hot air balloon. When you heat up that air, it becomes less dense, it expands, and it tends to rise and can even pull up a basket with a couple people in it in the air around it. Um, as this air rises, it expands because there's less pressure above it, less mass of the atmosphere pushing down on your head as sort of you rise up there. And the air expands and it cools automatically. And this is called adiabatic cooling. It's just what happens when the pressure is released, the temperature goes down, and it's what happens with a dust-off can when you press it and the air sort of expands. It also cools. So we'll show you a little demonstration of that in a second. With that lower pressure at high altitude, the air expands, and the colder air at altitude can't hold as much water. So if I have hot air over the ocean that can hold a lot of water vapor, it rises and expands and cools. That water can no longer be maintained in the water vapor phase, and it condenses to rain and rains out. So over the equator, hot air rises and forms the world's tropical rainforest, because as that hot air rises, the cooler expanded air can't hold the water, and all the water falls out of the atmosphere and comes back down to ground. In other areas, that cool, dry air becomes more dense than the air around it, and it begins to sink. And as that air sinks, it becomes more dense and it becomes hotter, because just like a compressed gas, like if I take a bike pump, again in the demonstration in a second, I make it more condensed, it forms dry air, which pushes down on the surface of the Earth and causes areas of the world's deserts. These high pressure zones are good weather areas, and low pressure zones are usually the areas in the middle of storms. Go. Today we're going to talk about how gas, when it compresses, gets warmer, and when it expands, it gets cooler. So this is a tool called an infrared thermometer, and I just point this gun at an object like this dust can, and it tells me the temperature. So this is 25 degrees Celsius, and what I'm going to do is this, moves dust off computers, so I'm going to spray it. And then I'm going to measure the temperature of the metal can, and it went down to 20 degrees. So it went from 25 degrees to 20 because that air that is compressed expands and automatically cools. Here is a bike pump that's measuring 25 degrees, and I can take it and pump the air into it, which compresses the air down the barrel, and do this multiple times. And then what I measure is that it is 30 degrees. So the air that is compressed gets warmer. This happens in the atmosphere when air descends over the desert, and warm, dry air is then because it's compressed down at the lower elevations. And if air rises, like going up a mountain, or if it is rising in the atmosphere, it cools off and then can't hold any more water, and it rains. So now we're going to continue with a few more weather basics. Land heats up faster than water. Water has a high heat capacity, and it takes a long time to boil the water or heat up a lake or the ocean. The ocean in the beginning of the summer is often cooler than the land when we get into that June, July temperatures that are really warm, and we can cool off in the ocean. But if we go into the fall, the lakes remain warmer longer than the atmosphere, and the land cools off faster than the water. And so the water might still be warm in August, September, or October, even if the land gets quite cold. Winds generally flow from high pressure to low pressure. So if I have a high pressure system, the wind wants to go from the high to the low. So if I'm pushing on the air mass, it tries to move away from where I'm pushing, the high pressure, and goes to the low pressure where there's no resistance. Wind circulates counterclockwise around low pressure systems in the northern hemisphere. And this is due to the fact that the Earth is spinning. So the world has a little bit, because the whole Earth is spinning, things that are moving are always pushed to the right in the northern hemisphere. This is called the Coriolis force, or the Coriolis effect, and I don't have time to go into that right now, but it does say that if you have a low pressure in the middle of a storm, where it's usually rainy, the winds go counterclockwise, so that the winds trying to push inside then have the Coriolis force pushing outside to balance it and become a stable system. So these storms can be stable when there's a low pressure in the middle and the winds are moving counterclockwise in the northern hemisphere. So when you think about a system, a weather system like this spinning sort of storm system, again, we can go back to where does the energy come from? Where are the boundaries of the system, and what's in and outside that system? So here's a couple weather phenomena that we want to think about. Sea breezes. Sea breezes occur because of these basic facts about weather. Land heats up faster than the ocean. So in the day, as the day goes on, the land air heats up faster than the ocean, and it rises and pulls air from the high pressure of the ocean to the low pressure that is created over land. And this cools has a sea breeze and a cool ocean breeze in the afternoon, sort of in coastal areas. This reverses at night because the land cools off faster than the ocean, and so the cold air over the land sinks and pushes on that high, clear, sunny, not sunny, but you can get a clear evening sky with this high pushing the cloudy, foggy weather offshore during the night. And this becomes diurnal, where you get a sea breeze every sort of afternoon in the summer. And this can happen not only on the ocean or the sea, but also on big lakes. So you may be very familiar with a lot of different weather maps, and just a few hints on reading weather maps. There are high pressures with H's and low pressures with L's. The high pressure generally good sunny weather. Low pressures generally stormy or rainy or cloudy. And we have fronts, and so these are fronts with the triangles moving towards this direction or in this direction, and both can be the incoming or moving bad weather towards your area, and we'll see a little bit more about fronts. There are also forecasts that can forecast 3 to 5 days in advance, maybe up to 10 with some uncertainty, and really not a lot of ability to forecast more than 10 days ahead of weather. Sometimes the video forecast or the data in the past, seeing how it's progressing, can show where it's going to happen in the next few hours or days, and these video forecasts can be very good for visualizing what's going to happen, predict whether it's going to happen in the near future. So here is a moving sort of video forecast, and again, the green or the red is the things that are impacting a radar. So the clouds and water droplets can show where that rain is going to go, and this is just past data that is predicting into the future here the next couple days. These forecasts are pretty good for the next 3 days and okay over sort of 10 days, but they're based on models, and models are understanding all of these weather basics and a lot of the complexities that we haven't discussed about where wind moves and doing that on a spinning earth, and high pressures and low pressures and different altitudes, etc. And the things that you can measure out of weather are temperature, pressure, wind, rain. These are things that you can measure, and we'll learn a little bit more when we watch this little video about weather forecasts.
So this is a typical pressure chart, also known as the synoptic chart. If we strip everything off it now and just focus on the low and high pressures, starting off with high pressure.
Another high pressure area expected to form in the northwest.
In the west here, we'll get this ridge of high pressure coming across.
A little ridge of high pressure, a good deal of dry, bright weather.
A high pressure system in the summer is when the air is descending or falling towards the ground, generally bringing settled fair weather. The air under a high pressure dries, so there's less moisture, bringing dry and fine conditions. So if you're ever planning a picnic, high pressure are the words you want to hear. And the words you won't want to hear are...
Got low pressure all the way, lots of isobars means it's going to be quite breezy.
And the troughs of low pressure in the north are moving south as expected.
The next area of low pressure spreads the weather fronts right up across the United Kingdom.
A low pressure system means that the air is rising. As air rises, water vapour condenses into clouds, which may also bring rain, which of course is perfect if your garden is in need of watering. Something else you'll spot on this chart are the white lines. These are the isobars, and they join places together of equal pressure. And you can see that the wind strength here, the isobars are quite well spaced. It's going to be a lot less than it's going to be over here in the Atlantic, where the closer the isobars are together, the windier it's likely to be. Another really common weather term you'll hear me talk about are fronts.
This frontal system will be pushing across and bringing with it cloud and outbreaks of rain.
Good afternoon. Well, there is a fresher feel to the weather today, and that's mainly because we had a cold front going through last night, which brought a band of rain.
We still have these fronts to contend with over the next 48 hours.
What a front shows is a line between two different masses of air. A cold front, represented by blue triangles like this, introduces cooler, fresher conditions during the summer. And you've guessed it, a warm front, represented by red semicircles like this, shows that warmer air has been brought over the country.
So weather forecasts can predict different types of weathers, like if it's going to be sunny or cloudy, whether there's going to rain, or there's big storms like hurricanes or even tornadoes that spin off of hurricanes. The weather is sort of what's happening today. How do I dress for the day? How do I plan for this week? Not really talking about climate, but if you skip over to this this other website at the at UCAR, you can get a lot more information than we have time to discuss about today. So this website, the University Corporation for Atmospheric Research Center for Science Education, has many resources that we just didn't have the time to provide the detail for, but it's a great resource to look for things like understanding better weather fronts with diagrams, and many resources like games and simulations, videos, images, so many things that are useful for working with your students. So I want to discuss the polar vortex. This is one area where weather and climate sort of intersect, and oftentimes could make some confusion in certain understanding of weather. Some people say, how can places get so cold in the winter when there is global warming? And so I just want to explain a little bit about the polar vortex, which is a very stable circulation in a counterclockwise, so we're looking down at the North Pole, counterclockwise direction around the North Pole of the jet stream of winds. And these strong winds keep the cold air isolated over the pole, and the warmer temperatures and winds are separated because of this strong jet stream. It's stronger in the winter when it's colder in the North Pole and weaker in the summer. But as you warm the Arctic due to increasing greenhouse gases, creating more warm air in the winter over of the Arctic, what happens is these winds get less strong. The low pressure is less strong and the winds are less strong in that system, and they begin to wobble around like this. And so when this cold air sometimes descends to low latitudes, this time over the center of the United States, we get the very cold Arctic temperatures. The prevailing jet stream westerly winds push this wobble along. This might last for 3 days or 7 days or 10 days. And then the warm air that usually is separated comes in, and it can be much warmer than it normally is. So you get more variable weather due to the polar vortex wobbling than you used to when you had a very strong polar vortex that keeps the cold air cold and the warm air warm at lower latitudes. So this instability can lead to large extremes in weather, very cold for a period and then quite warm for a period, especially in the Midwest. So in summary, we covered a few weather basics to explain some of the types of things. The state of the atmosphere at any time as measured by these properties: temperature, is it hot, is it cold? The pressure, which tells us something about good or bad weather and where it's going to head. Whether it's raining or snowing or it's cloudy or has fog, this type of water in the atmosphere. And the changes in the weather are due to energy transfer, differences in heat transfer, and prevailing winds. We can predict the weather in about 3 to 10 day time period, and there are very consistent patterns of weather. We know there's winter weather and summer weather. We get blizzards in the winter and we get heat waves in the summer. It's sort of a not vice versa. This is the impacts of weather can impact us in what we do. We choose to go outdoors or not, or go to a picnic or a vacation, and the clothing that we wear each day.